the Missouri Sedimentation Action Coalition. On the other end, running our Zoom from her home is Sandy Stockholm, which she's been with the organization for 20 plus odd years. She's our communications coordinator, and previously, when it was just her, she did all this stuff. So come on in. So she's on the other end. I've been doing the executive director here for about 2 years, a little over 2 years. So again, I welcome you here. Make a couple other introductions, both online and we have some folks in the room. From the MSAC side, I'd like to recognize we have Mark Simpson here, Niobrara resident, longtime board member and president. So, and he still is a member. He's been a great help coming with this. And Larry Weiss is online as well. He was a longtime board member. These two gentlemen have worked on this stuff for a long time. Worked with the Corps of Engineers and with the local officials trying to get to where we are today. So I thank them for joining us as well. And we may have a couple other board members online from the area. So just in the way of introductions, Paul Boyd will be your primary presenter here a little as soon as I get done, is from the Omaha office of the Corps of Engineers. Again, a long time relationship with MSAC and dealing with this river and issues in Niobrara and the area, so a lot of folks know him. Chuck Dealing is from ERDIC, which is a research branch of Corps of Engineers, and he's basically the equipment owner and operator that comes with the bed loader stuff. And then Nathan is with the USGS, and they're here in a collaborative environment, and Paul will explain to help gather additional data on what exactly the environment's doing today in the river, so that it's a one-shot collection to get good data. Couple things on the MSAC side for maybe some folks that aren't as familiar with us, or as a good refresher, MSAC's a nonprofit. Our mission is to help educate about the sedimentation issues and adding to the longevity of the upper Missouri River system. We don't lobby Congress, we don't lobby public officials. That's not what a nonprofit does. But we do work with them to educate them, to bring them in on the problem, to help them see what's going on, see possible solutions. So we did have a congressional staffer here yesterday from the South Dakota side. Looks like we'll have one from Nebraska tomorrow. This is a way to get to the federal side. A number of other state and local officials have been invited or we've communicated with about this project and about the other items. So that they're aware of what's going on. Now, well, we're entirely, I shouldn't say entirely, but we're putting a lot of our effort right now into the Lewis and Clark area and the upper reaches up to Fort Randall because of another particular project that we're working with the Corps. MSAC does cover the entire upper Missouri River system. And Lewis and Clark Lake and the reaches here are definitely the most advanced in the sedimentation and siltation issues that are affecting the reservoir system and impacting their lifespan. And that's really what we want to do. We want to keep the lifespan, or to expand the usable lifespan of the reservoir, the river, and the dam for their intended and planned purposes, which are set by other agencies, not MSAC, but recognizing that the dams have caused some issues. And I'll say some, there's other environmental things that are going on as well. But there are opportunities and there are options to help extend the lifespan. And I think Paul will also bring this up, but really, Gavins Point Dam, we're looking at about 70 or 75 years where they will be impacted to such a point that their operations will start being impacted and reduced, and some of the stated purposes will no longer be able to be carried out. When you think 70 years, we're already halfway. That means half of the lifespan of the dam and the reservoir. So we certainly would like to extend that here. MSAC is not a dredging operation. We're not here to deal with or to help necessarily with what has happened already, that's an entirely another large scale thing that can happen, and that would involve a lot more, probably local governments, commercial entities, stuff like that. So a lot of times when sedimentation comes up in the river, that's a lot of things, that first thing that people talk about is you're gonna dredge it out. That wouldn't cure any future problems. That would probably just make us feel good for a little while and spend a lot of money without getting ahead where we need to be. Recognizing that there's going to be sedimentation in the river it was here long before we got here. It'll be long after it's trying to extend the usable life because of some of these man-made items that have come up. What we're here tonight for is actually part of an outreach of an ongoing program that we have a couple more years to go. It's called the Section 22 Planning Assistance to States Program. It's something that MSAC initiated, back in 2018, I think, 19, somewhere in there. As a nonprofit organization, we're able to ask the Corps to do research on this topic. And what the topic is to come up with a sediment management plan for Lewis and Clark Lake and the upper reservoirs here, or the upper reaches. This is important because, one, it helps further the messaging of sediment issues here. And two, a sediment management plan is an official thing. It's something that would be approved by the Corps. And I think, as most everybody knows and understands, we can talk about it, we can educate folks, you can go to officials at all levels and ask them to do something. But if you need funding and you need resources, you really need to have something that has been quantified down and has some research done into it and been approved to go back to and start going through. Recognizing that that's probably a compromise for some folks, but that's the way that we would go forward. So we just finished up phase 2, and those items are over there on the boards. Phase 2 was the heavy research portion of it, and taking about 5 years. Kind of a little extension with COVID and a couple other reasons, but ultimately last winter, right after Christmas, Paul and his team and the folks down there finished up phase 2, and I guess we'll say formally published it. It's a research document, so it's an input to this. But there were about 4 things that came out of that now that MSAC, working with the Corps, and now we'll look forward to and start putting more effort and more resources into these 3 or 4 items to address the situation. Because there are many things to do, that could help it. There's no one thing that will ever help it or solve the problem. One of the things that came out of that was this potential bedload collector. It's been out there before. The part that would help is it's relatively inexpensive. It's a pretty dumb piece of equipment, really. It is commercialized. There are areas that do this and can gather the sediment. What we needed to do within our groups was to actually figure out, can this work? What does it look like at scale? When we put it in the water, what happens? Is there so much sediment out here that if we just bury the thing and it's going to be any good? Or is there so little that it doesn't make sense? Because ultimately, we start pulling some sediment out, and when I use the term some, it'll be some. We need to find something to do with the stuff, because you just can't pump it on shore. You can't pump it into a sandbar. I know some of those have come up. The enormity of the amount that's coming down and entering the river is kind of mind-boggling. And even when you get to the point of, hey, let's see if we can get a few percent of that out, because that will make an impact. It will be very, even that's a significant amount. And over time, if you want to keep it going, there has to be some beneficial use other than just going in the gullies and everything else around here. So part of this project today, what we're here this week, is to actually have some stuff in the water and see what comes out of it and to what quantities and what type of stuff it is, which is what they're going to talk about, which helps the MSAC side to work with other officials and economic development and companies to say, hey, here's something that's there, and it's going to be really cheap, like almost free, probably by the time you can get to it if you commercialize it. Because the project is here, just down the road from here does not mean that's where a commercial site would go. I won't get into all the things that it takes to do even a small project like this, but it does take a lot of organizations. A lot of folks have some degree of oversight, particularly anywhere along the river, as most of you know. So it'd be a little complex to do a commercial operation here. But if you start going further up the Niobrara, where you can get out of some of the environmental and recreational areas, commercialization becomes much more plausible and something maybe that can be done in the future. So to help manage that a little bit. So the fact that we're actually able to do this while we're still doing the Section 22 study is fantastic as well, because the way the timeline would have run would be, you get done with the study, you get these 3 or 4 things out of it. Okay, then we go back and try to resource to do it. Well, in this case, this is something that's been out there for a while. The Corps of Engineers has all the equipment, so they could do it and do the test. On MSAC last year, we worked with Paul and folks, and we put in a grant request to the EPA to actually start this project and do essentially this right here. We were unsuccessful with our grant. We did learn a lot, but because of the help and working with the Corps crew, they were able to take it and go in and do an internal program and ultimately got this funded for this year. And so we're still able to get it done, which is a good partnership and a great way to approach the problem, and allows us to do this in conjunction, in parallel with the rest of the study. It does shift the resources for a little bit. So this has been a focus this summer. As we roll out of this and get into the winter, we'll return to doing what's called phase 3, which is taking what's out there now for the study, for the plan, and putting together that sediment management plan, that draft that then can be taken up and presented for approval, which then provides a framework to continue working with anyone that's involved to see that. It's always going to be a compromise. Compromises are always good for somebody and bad for somebody else, recognizing that. But again, with no single solution, it's going to take 3 or 4 things to do this. So it's fantastic that they were able here to come up this week and do this and get the data to take with. Go on to do that. So that's that. A couple just little safety things, I guess. A couple things about the project site. Since we're here at the Fire Rescue Center, if anybody needs an ambulance, Gina's in the back, so we can take care of that. If the fire whistle goes off, we'll just stay sitting here and we'll let those guys do their thing and get to see it from the inside, I guess. Bathrooms are just back down the hallway to the right. If anybody needs to go, there are some snacks and stuff like that back there. So if you need to, please grab those. As Paul goes through, I'll let him do his presentation, but there'll be some question and answers. And obviously, some of you are here with some other topics in mind that you'd like to either visit with them or with us about. If it's not directly to the bed loader, but we'll be more than happy to address those when he gets done with what they've been doing so far this week. And we'll certainly be here for a little while to do that. So with that, again, we have some folks online, so being mindful of them, I will turn it over to Paul and we'll let him take over his presentation.
All right, thanks, Scott. Great introduction there. Took a little of my thunder. That's fine. I don't have to go through those things again. But anyway, as Scott said, my name is Paul Boyd. I'm a hydraulic engineer. I'm a sedimentation specialist in the Omaha District Corps of Engineers. I've been with the Corps 22 years, and I've been around the Niobrara area about 21 years and 354 days, because this was my first day of the job. They're like, have you heard of week 12? Well, I have now, so I'm still working on an EIS there. But yeah, so I have, we've had a great relationship with MSAC for literally going on decades now. And I hate to admit this out loud, but this is the first time that we've had a project that actually moved a grain of sand from point A to point B. So while it is a small amount of sand, I'm going to take that as a group victory there, that we did something there. So we'll go through a little bit of summary. If any of you were at the annual MSAC meeting a couple of months ago, a few of these slides are summary, but really just wanted to focus on what's going on down here right now, and give you some pictures there of what's going on. Scott alluded to this section 22, this Lewis and Clark sediment management study, and resulting in a sediment management plan. And this phase three, expand the technical analysis to consider emerging technologies. Okay, this bedload collector in this specific environment in the Niobrara fits into that category. It was one of the 4 kind of sediment management methods that were recommended out of phase 2. That you need to find a way, or you need to figure out if these methods, how well they would work, where they would work, to what cumulative effect could they reduce sediment impacts in the lake, in the river, how much might they extend the life of the project. So next slide, Scott. So that's what we're doing here. These are bold slides. These are slides we put in the presentation and proposal of the bedload collector itself. There's think of it as a speed bump in the river. You'll see a little larger picture of it later. But I like to call it a river Roomba, right? It collects, it kind of essentially vacuums sediment through some grates as the river moves sand along the bottom of the river. So these were from the proposal. You know, as a reminder, one of the reasons we're kind of focusing on the Niobrara is that at least 50%, probably 60-ish% of the total sediment that ends up in the Missouri River from a delta that extends literally from Lazy River Acres all the way down past Springfield, 60% of that material is coming out of the Niobrara. So if you're going to look for a place to have a big impact on the problem, you go to the biggest offender in the system. So, all right, next slide here. So we are here trying to find efficient ways to harvest sand because it's simply down to a matter of economics when you get right down to it. If money was no issue, we just go out and dredge it every year, find something to do with it, and go on with our lives. Money is an issue. It is in every one of our lives, and it is for the federal government, and there is not a magic pot of money for this project. Feels like there are magic pots of money for other projects, but not our project. Okay, so how do we turn sediment? We have a huge resource here, literally billions of cubic yards of a resource here. If you take what's been deposited here over the last 70 years, 4 million a year, 4 or 5 million cubic yards a year times the last 70 years, 3.5 billion, rough math, cubic yards sitting in the system right now. Could we, you know, use any of these? Could we generate or commercialize the product that we have, the resource that we have? The Corps of Engineers and the federal government in the Water Resources Development Act in 2020 put in a stipulation there that we kind of cut down a lot of the barriers to giving away this resource, the sand. Okay, we had a whole set of regulations about giving away, you know, products on our projects. We shortened that and we made that a much quicker process. So if there was someone who came to us and wanted this sand, we have the ability to essentially give it away with very little paperwork, which I'm understanding government and paperwork go together, but as governments go, we have really shortened that. Now we need to find somebody who wants it, right? And as a note here, one of the things that we're looking at for next year, Scott alluded to the fact that, and I think we were talking earlier, we did a prize competition last year with Bureau of Reclamation for people to come up with new ways to move sediment. We had some ingenious kind of autonomous type sediment harvesting machines that people designed. We're hoping to get pilots of those next year too. But one of them we'd like to do next year is do one of these prize challenges for commercializing the sediment. And those prize challenges are run at the national level. They come with sometimes up to $100,000 in prize money to a citizen who comes up with a great idea, type of thing. And we feel we've had great results doing this pathway in the past, and so we're going to try it again on this commercializing of the sediment. Next slide, please. So this project, this Bedload Collector Pilot Project that we're doing, is supported by the Corps of Engineers Regional Sediment Management Program. It is a program run through our navigation program. Okay, it was originally intended for beneficial use. How do we keep sediment out of navigation channels? How do we keep commerce going? How do we keep the Port of Long Beach open and the like? But it is since, fortunately, it has since expanded to inland rivers and reservoirs. So we put in this proposal that was almost a mirror of what MSAC and the Corps put together to the EPA last fall. We took that proposal and were funded to, find a location and do all your coordination. Work around College sturgeon and piping plover seasons. Get some local support, do a 1-week collection, measure it, fill it, collect a little of it and see how it works, instrument and monitor it, measure the impacts of it on the river itself, host some field days, outreach during the week, and then feed back that information, because this is one of those 4 methods for phase 3. This will go right into that report. There will be a number of public reports on this that we can use. The Corps, both Chuck and Omaha District and the Research Lab will issue a report. USGS is funded to provide a data report of everything they collect and all public documents, which was we thought very necessary when it got done. Next slide, please. Possible locations. We looked at 2. Okay, here's the Highway 12. This is the Mormon Canal side. This is the campsite at the state park. We looked at the site just off the walking path over here, just upstream from the West Bank. This is the site. Has everybody driven by over the bridge and seen the site out there? See a couple of big tanks and a generator sitting out there. Yeah. So that's this site E. We're right on the point right there. We did coordination for rights of entry and for T&E and all the habitat and all the environmental stuff on both sites, just in case river conditions were one way or the other. And we made a decision about a month ago that the site we're at now is the one we we're going to go ahead and use. Next slide. I put this one in there. This is from a project that Chuck did back this spring, but just showed you here. This is our rivers. Their speed bump right here. Set this on the bottom of the river. These are some pumps over here, and the sand goes up. And as it goes over this ramp, this is graded, and that sand can fall into that grate. And we've got essentially a vacuum pump that with water sucks it out. So it's essentially a passive system. Set it in there, you leave it, just let the pumps run. Yeah, and then just probably saw the silver control box. We've got some tanks down there. We use those for the kind of the science part of it, measuring at what rates we're collecting material. Next slide. This is kind of similar to what we have set up down here. That was this spring in Eau Claire. Next slide. And then we've updated it with, I've got some pictures in here of our current setup. So we scheduled for this pilot week. We were hoping to do this in August. Coordination was more than I expected, to be honest. I did not know going into this in March that I needed a research permit from the National Park Service to do this. I found that out. I did not know that I was going to have a right of entry from NDOT to get off the embankment to get to Corps-owned property. We did, and with some great staff that we've got in our real estate and our environmental compliance group, we finally got all that done, but that did necessitate that we pushed it back to this week. And so on Monday, we did some initial setup. The equipment actually showed up Tuesday morning. And so yesterday morning, we went from trucks arriving to sampler in the river in about 5-6 hours. Today we were setting up doing some initial testing. Our formal testing and production experiment, as it were, will happen tomorrow down on the site. At this meeting this afternoon, and then we'll talk a little bit later about there's a possible field visit tomorrow evening and another one on Friday morning. Right after we're done on Friday, we'll break down site and then stage everything and start getting equipment out of here. The last of the equipment may not leave till Monday, but then we'll make a real effort to kind of grade and smooth off the site and all of that, and try and leave it as least disturbed as possible. We were talking about, well, here, get my environmental and real estate approvals. I was going to have this done on July 30th, but well, I got the NDOT real estate approval last Friday, about 3 minutes before our project guys started mowing down there. So just in time, as it always is. But we got it done. That's the key. We eventually got there. Next slide, please. Just a reminder, this is an old fact sheet. There are some really great fact sheets that a lot of folks in the Corps really were really impressed with, and just kudos to MSAC for their strong messaging. I can take these products and work within the agency, and they're like, well, these are what we should be doing. So kudos to MSAC on that. Next slide, please. Pilot Project Week. Next slide. So here is, if any of you were around on Monday morning, 2 mornings ago, we created a little bit of a traffic jam on Highway 12 because all of our local support in heavy equipment has come from the Gavin's Point project office. So all part of that, and I think Chuck would echo my sentiment here that that crew has been absolutely amazing. That's part of the their commitment to a good relationship between the project and the community, and supporting us on doing science and on sediment management. And we just kept asking and asking, well, can we use your excavator for a week? Yeah, can you do this? Can you do this? And not once did they say no, to the point where we felt bad. We're like, probably shouldn't ask them because they're going to say yes. So maybe slow down. But so this is a Gavin's Point excavator, and this is all the equipment arriving on trucks on. This was early Tuesday morning. Snatching all this equipment off of here and moving it down to the site. Next slide. And then setup. You can see we're down at the site here. There's the Niobrara in the background there, but we had to essentially plumb the whole system together because the intent is we need the harvester, we need the collector to collect sediment and move it up through all this hose work, and then we need to be able to measure it. Both the flow of water and the sediment. We need to determine what kind of sediment and all of that. So we got that set up. Next slide, please. What can you see from Highway 12? If you drive by today up in the front, you'll see this generator. We'll look at it. You see there's 2 orange floats. They're only about a foot in diameter. Okay, that's your indicator. That's where the collector is. It's sitting under the water surface where those 2 orange floats are. We'll talk a little more about this in a minute. This that looks like that big jumping pillow that your kids bounce on at the Halloween, trick or treat Halloween fair. This is a big water pillow right now. It's like a geotube. It's a synthetic textile. Okay, so what we'll do, here's the supply line. This is the discharge line from the collector. It's pulling out of the collector. It's going through this line. It goes into an opening in this. And think of this as a big coffee filter. Okay, we pump the sand and the water into it, and all the water leaks out around it. And I'll show a video. And so I don't forget here, I use my family's finest pans. Okay, so don't tell anybody about this. Don't get me in trouble about this. But these here are the 2 different breakdowns of sediment that we're collecting inside the bag and then in the flow that comes out of the bag. Now this stuff right here is about 1/10 of a millimeter, and you could level your pavers with it and all that kind of stuff, because essentially it's through a filter because it is coming out of that bag. But we'll leave these up here and you can look at these. So this is the really fine stuff. We're not catching this in the bag. It's seeping out of the bag. But so we measure it in the water coming out of the bag. This more coarse material, which looks a lot like playground sand, right? That's what's getting caught in the bag. So for us to do our science, it's this plus this per day. How much are we collecting, right? Because the unit we're talking about, how many tons per day could we catch with this thing? And then this is a little one. What if we make a bigger one? What if we put in 20 of them? What if we put in 100 of them? And that gives us the idea of how much we could scale this. And then are we saying we could make a 1% difference in delivery of sediment? Could we make a 10% difference? Could we make whatever? So that's kind of we collect these sand samples and we determine what the production rate is in this little pilot guy. And then in the report, we're going to talk about what if you did it bigger, is kind of how that's going to work. Next slide, please, Scott. So this is our first attempt. And usually if you call it a first attempt, there's a second attempt, right? So this is, as you know, as soon as you stick this thing in the water, it's like, hey, the current starts kicking it off right there. And so this is our support crew from Gavin's Point, putting it in with the boom of the excavator. There's those two orange floats that you can see sitting right there. And so, the intent here is we want to set this thing in so it's perpendicular to the flow. So all of that sand that's bouncing along the bottom of the river goes right down into those grates right there. So on the first one, we put it in the river and it took a little turn on us. So next slide. So the beauty of it is that we just tried again. We changed the angle and we kind of lined it up and we set it in a slightly different spot. And there's Chuck doing his thing there, holding the rope. But yeah, you can see that there's the pumps on this end. When you fire this up, essentially it's the pumps are sucking water out from below these grates and out those tubes. Next slide. And then this is going to be a little hard to see here. I don't know if you can see the trickling right here, but this is that geotube weeping. Okay, so the sand and the sediment laden water is we're pumping into this, and this is essentially our coffee filter, and there's much clearer water oozing out of the pores of the tube. We ran it overnight, and yeah, there's a lot of water in it, but that's a big pile of that coarser sand sediment in there. Our concern right now is we don't want to run it too long because it's a bag that can hold 20 yards. And our excavator cannot pick up a bag full of 20 yards because 20 yards of sand weighs about 45,000 pounds. And our excavator's not that big. So we may shut the pumps off before we get to that. But this is a great problem to have because this means we're actually collecting sand. That for our little test here, we don't want to collect too much because we may not be able to move it. Next slide. So this is, and we also did some tests. You can see coming out of the end there, it's kind of some darker water. That's some fine, some coarse. This is the coarse stuff that's in that one tray. So we essentially just put a filter sock to do our testing on the end of the hose. And, we collect that for say 15 minutes. We know how much of that coarse material it is. And then we say, well, what if you ran it for 24 hours, 24 days? You can figure out how much of that is. So the coarse material we're sampling this way, and then the real fine stuff you see in the sugar sand you see in the tray, we sample this water, and then we send that to the lab because the sugar sand is too small. It goes through the mesh here, but we do capture the entire discharge through the collector. Next slide. So here's thanks to Garrett who came out for MSAC and took some really cool. I just like this one because it's like a slow motion. It's like a babbling brook in the Niobrara. But yeah, this is just as we're placing it right here. You can see the excavator is still connected to it. So he finishes the placing here, and then it sits in the river, and we'll have it in there until Friday, and then we'll have to have some unlucky soul wade back in there and have these two floats reconnect all the cables, and then we'll snatch it back out of there if it hasn't buried itself. Next slide. So a little bit right here, you'll also see the USGS impeding your daily commute on the bridge there. Good job, guys, for causing traffic jam. So they are here. So the U.S. Geological Survey is here as part of a collaborative program with the Corps of Engineers. USGS is a federal interagency sedimentation project, which is similar to our regional sediment management project in the fact that we proposed this project to get their funding to do that. And really the takeaway here is that their data collection is going to help determine if there's a significant impact to water quality while the collector is operating. And that has been a concern that we've heard over and over from Game and Parks, from the Park Service and all of that is, are you disturbing, are you creating turbid waters? Are you making a muddy plume while you're doing this? Because if that ended up being the case, then you're pretty limited on where you could put one of these things. And if these are to be cost effective and to be very inexpensive, they have to be put in for long durations. They have to run 24 hours a day, you know, literally like for a whole season, you know, from ice out to ice in, and find a use for that and a number of them. So if we were, the reason we're all the way late in September is that, you know, we couldn't be in the river for the pallet season, pallet spawning in April. And then through the middle of August, we couldn't be in the river for parts of it because of tern and plover nesting season. So that's where we got pushed. So the hope here is that if this research shows that once you put it in, it's kind of a non-factor. Really doesn't disrupt anything. It just kind of sits there and does its thing. It's very non-intrusive. You can kayak right over the top of it. And if it wasn't for those two orange floats there, and if it was in another foot or two of water, you'd never even know it was there other than the two hoses coming out of the ground or out of the water. So they are constant. So USGS is constantly measuring velocity, total flow, sediment concentrations, both upstream and downstream. This is our collector right here. This is some of their downstream instrumentation. And what we do is we change the rate at which we take sediment out of the river. And they look if there's a response in their instruments to say, yeah, we are having a local impact or not. So they'll have a report, you know, next spring like we will. We think that's going to be really valuable to expanding the application of these, because we think we can show that they are kind of benign and don't really have any significant impacts while they're just in their. Next slide, please. So what's next? We will complete our sampling plan tomorrow, which is measuring sediment and taking water samples. We do have that one GEO tube out there that's just filling. We're collecting that coarser material in there. And we will move that through all our coordination with the Park Service and getting everything set up. We said, well, we're gonna have a bag, you know, 5, maybe 8 or 10 yards of sediment. We don't want to put it back in the river, right? The whole point is to beneficially use it as little as it is. Let's at least symbolically not put it back in the river and find something else. And Park Service says, yeah, we got a bunch of potholes in our, you know, in our driveway, and we've got this beach area down by their area. I was like, you can have it. So we're going to take it to the Gavin's Point project office, and then Park Service is going to use what little sand we have from this pilot, but rest assured, it's not going back into the river. And then we've got these Thursday and Thursday evening and Friday morning site visits. Scott, there is some availability for the one tomorrow night. If you are interested, it's 5:30 tomorrow night. If you are interested in taking a trip down to the actual site, just 30 minutes to see things going down there, talk to Scott after the meeting. Please do not go down there on your own. It is an active work site. There are 3-phase wires hanging in the river. There are generators running down there. There are trip hazards and all of that kind of stuff. So please, if you want to see it, talk to Scott, because there will be a group going down about 24 hours from now on Friday morning. We'll clean up on Friday morning. We'll analyze samples. We've got a couple of reports that we'll have to generate. And then this the outcomes of this go directly into this phase 3 study right here. And then as we think at a higher level, it's more look for future opportunities for permanent installations or even longer pilot. And Scott made a good point earlier as I wrap up here that the location that it is at right now was a location of convenience because it's close to resources. You know, right near the bridge, we could get in easily and get access. For a permanent installation, it makes a lot more sense on smaller tributaries or farther up the river where you have a smaller river to work with. You can control the river over the collector, and then you can maybe have distributed uses of that sediment. But if you add all of those together, you know, that's the contribution you're looking for. 10 of these things each pulling out 15,000 yards a year or something like that. That's how we incrementally add up to a benefit. I think there's one more slide here, and simply to say a big thank you to our 2 funding programs here. Again, Gavin's Point Project Office, the outdoor maintenance crew, you know, lake manager Justin Scholl, who many of you know. They have been amazing in their help and giving up their time and resources, environmental real estate teams, and then all of this support from the village, Knox County, and then all the coordination efforts that went on with Game and Parks and DOT and Park Service and the like. So I think that is the last slide I have on the collector. So yeah,
I'll just clarify a little bit on tomorrow. So first thing is tomorrow over at the campground, we have site number 25 is rented by MSAC. So you can drive over there. That's directly across the river, so you can see it. We've got some binoculars and spotting scopes, so you can take a look at it there. It's very easy access. Myself or Sandy will be down there most of the day, probably starting about 9 until about 4 in the afternoon. And then the field days that he mentioned, we do have some availability for seats. I got to thank Stacy in Knox County. They're offering up a minivan along with the Corps of Engineers. If you would like to go, I have a sign-up sheet. We definitely would like that signed up so that we know, because we do have some other folks and other groups that we invited separately to do that. But you can jump in here. This will not be redone tomorrow. There'll be a real short version, but then we'll go down to the site. You can actually walk down there. And these guys will actually take you through the pictures if you want to see that. It's generally pretty good, but it's a little rougher terrain, a little softer sand down there, but you can get right to it if you're able to. So that's tomorrow, Friday morning. A little more limited seating, but we can do that. The site visit is really probably about 20 to 25 minutes. So we meet here tomorrow at 5:30. Who's here? We would take our seats down, probably shuttle if we need to, and be done to see actually how this stuff comes out.
Yeah, absolutely. And if you do stop by the observation site at site 25, you know, the team will be doing our research and doing our measurements all tomorrow morning. So you'll just see from the other side, you'll see a couple of folks scuttling back and forth, changing tanks and changing pipes and all that kind of stuff in the morning. But yeah, it's the easiest place to see it without stopping on the bridge. You can just do that. So yeah, so that's what we've got here. I would say, and I'll speak for Chuck here, we are mildly optimistic on the amount of sand we collected with this little tiny collector. And so, you know, to a point, we have to kind of adaptively manage how much sediment we're getting, how we sample it and all that kind of stuff. But like I say, we're to the point where, you know, by the end of the week, we got to make sure that that bag's not too full so that we can actually pick it up and move it somewhere to do that. So I would open the floor for questions on this study that we're doing here. Anything specifically about? Yes.
Just wondering, like the pump and creek, how it opened and kind of got its own channel going into the Missouri River.
Yeah. Probably that is certainly a concern. Absolutely. this technology, not really, it's not, because that is an area where, you could probably put one right downstream of the, or right upstream of the bridge on Raider Swanson Road, or even farther up closer to the Highway 12 or something like that. But because it's not as spring bed as this one, it's sometimes it's flowing a lot, sometimes it's just a trickle. It may not, I guess, I won't say it wouldn't work there. I would say that it's probably not going to generate the same type of results there. Most of the deposition in Ponca Creek is, of course, due to the backwater effect, the rising of the Missouri. So the sediment coming down Ponca Creek's got nowhere to go. Probably some sort of physical removal and reopening of that channel is going to be a more effective way to regain capacity of Ponca Creek than a passive system like this. So,
How many cubic yard or how many cubic feet does Niobrara River carry a second?
a second,
Could it be 3,000?
3,000.
Could it be 3,000?
Well, I mean, a median flow of water could be 3,000 feet per second. Do you remember what the gauge was today? 1,500? 1,800?
Around
1,800.
1,800.
So that's,
And we're low flow right now,
yeah, we're going into the fall. So now it's essentially just the spring fed supply that's coming from upriver. So 15, let's say it's this 1,800 cubic feet per second, right? That's the water and the sand. Okay, the sand in that is probably 5%, which doesn't sound like much, but 5% of 1,800 is what? 180 is 90. Let's call it 100 cubic feet per second of sand.
Remark earlier, it was like 4 or 5 million yards a year that it comes.
Yeah, so yards,
Okay.
not feet, yards. Yeah,
A year.
cubic yards. So, because that's, usually we do dredging and earth moving in cubic yards. Honestly, we usually do earth in acre feet because cubic yards, the numbers get so big. So we go to an even bigger unit, which is an acre foot, which is in an acre, which is a football field, a foot deep. Okay, that's usually how we track those, because like you say, when you get into cubic yards, it's in the millions per year. When you get into cubic feet, it's into the hundreds of millions per year, and the numbers get awfully big. But yeah, so in the lake itself, we're a little shy of 4 million cubic yards a year, every year that we catch, that we trap in there. But that does not include the reach from Springfield up to Lazy River Acres and the Niobrara. That's, I don't know that number off the top of my head, but I bet it's another million plus. So 5 million cubic yards a year. Yeah, and constant, right? Because we know that, the Niobrara flows all winter with that base flow. That's one of the reasons that this technology could work if you could keep it unfrozen, right? There's sand going by there in February. There aren't that many rivers in the northern half of the United States where you're moving a lot of sand in February. But this is one. So, yep. Other questions?
Hey, Paul, this is Roland Hotchkiss. How are you?
Yeah. Good evening, Roland. How are you?
Doing okay. Hey, my experience on
Good.
my experience on sandbed rivers is that when you put something on the stream bed, it kind of gets a local scour hole and falls into its own scour hole. So how is the unit looking
Right.
now that it's been on the stream bed for a couple of days? Is it stable?
So great question. Roland Hotchkiss, professor at BYU and engineering advisor to MSAC. Dr. Hotchkiss and I go way back. Talking about the process, right? If you put anything in the bed of a river, it kind of creates a shadow behind it. You get an eddy. Sometimes that material scours out and whatever you put on the bottom of the river falls into the hole. Okay, that's a real concern with this system. Because if you do and it falls into the hole, then it's not flat on the bottom and it can't collect the sediment and stuff. In this case, yeah, Roland, we're out there kind of walking on top. It's currently sitting in about 3 feet of water. So we can kind of safely get out there in waders and check what it's doing. And the end of the pumps is out of the water. So we can see whether they're tipping and anything like that. So far, so good. We did kind of nose it in upstream. We kind of tipped it forward a little when we installed it. Kind of planning for the fact that that might happen. We might get some rotation downstream. We haven't seen that yet, and I would attribute that to the fact, and you know, on one of the first video clips, you may have seen there's essentially a big steel I-beam skid that it sits on. You know, Chuck's crew built a frame that it sits on with the pumps, and I think that has helped considerably just with the mass. We've greatly increased the mass of this structure. And so that has helped keep it stable, and we're watching that. You know, if we needed to, we could always pick it up and reset it and put it back down. But so far, so good. We're pretty happy with the fact that once it's settled, we put it in yesterday about noon, and over the course of a couple hours, it kind of settled down. But for the last 24 hours, it's been in the same location. But we'll of course continue to monitor that until we pull it out on Friday.
Great, thanks.
All right, thank you.
Paul, this is Larry Weiss.
Larry, good evening.
How are you, Paul?
I'm doing
Question,
well.
when you are finished with what I'll call an experiment, will there be an after action report that shows the number of hours that the collector was in the river and what volume of sand might have been extracted during that time period?
Yes, absolutely. So as part of the testing we're going to do tomorrow, we're gonna estimate what we call a collection rate, how many tons per hour we could pull with this unit. And then we'll say, well, it was in the river for 4 days. We could have possibly removed this many tons of this material. Like, certainly that's not going to match with what we actually collect, because we're turning it on, we're turning it off, we're doing some samples here or there. We are running into that geotube when we're not doing the other sampling. But yeah, as part of this, you know, when we talked about setting up this experiment, part of the outcome is kind of do some almost kind of a thought experiment about scaling this up. If the efficiency that we see in the sample would apply to all or other collectors that we would put in the river, then we can do some simple math, like what if we put 10 of them in, what if we put 20 of them in, what if we put more than that? And so that gives us a starting point to have the discussion of whether the technology is doing enough if you put a bunch of them in to be worthwhile. I don't have the answer to that right now. I think we all feel that in the right application, when you have someone that can take and use the production of sand, it can be very beneficial, but one of them is not enough. You know, some of the installs, you saw the picture, this one's 12-foot wide. Most of the permanent installs are either 30-foot or 50-foot collectors. So there is the ability to put in a bigger unit if you're going to go to a permanent install. The question is, if you put in a few of these permanent installs, would it be enough to matter? You know, on an economic standpoint. So yeah, Larry, you'll see some numbers in the report about kind of conceptually how this might be applied, and how much sediment you might be able to harvest with a bigger installation.
Okay, thank you, Paul.
Yep.
The other meetings are open. This is the first one ever made, or has?
No, I mean, this is a commercial technology. It's a company out of Ohio that makes them. This is a little bit of a novel application because of what we talked about earlier. A lot of sand all the time, base load flow. Some of the other permanent installations are reclamation, river restoration areas. If you happen to have a contaminant, you know, that's stuck on your sand that's moving down your bed, this is a way to capture that contaminated sediment, pull it out of, you know, if you've got a heavy metal or something, if you've got manganese in your sediment or something, if you can pull a large percentage of that sediment that's got these metals in it, get it out of the system for treatment. So I forget, this is a company called Streamside Technology, and they've been around 20 plus years. But this is not the original kind of application I think they envisioned. So this is like, well, but can we use it for this? So, yep. Any other questions? If there are any follow-up questions, of course, Scott and MSAC, I cannot hide. So everybody's got my contact information. And just reach out to them. I'm more than happy to follow, handle any follow-up questions.
Hey, Paul.
Everybody, this is a big deal. We've worked for years to get to this point, and we should thank Scott and Paul and everybody involved, because it's a tremendous feat to get this done. And let's hope we get.
So yeah, so if we do more in the future, but I think, you know, the key is to do a little bit of science here to justify that this is worth following up on. And I think more than just the collecting of sand and the rate was, we were talking about this compliance and endangered species and environmental impacts and recreation impacts. I actually think that's a bigger takeaway of showing that this passive technology won't affect those things. So it really shouldn't limit our ability to put these in rivers. If that's the takeaway, I think that's more valuable than whether it's this much sand or that much sand type of thing.
The cost of it must be huge. Is that come federal, state, both, local?
I would say it,
You know.
well, I will pull out my federal checkbook. You'll see it has no checks in it. I would say this, and Scott was right when he said that earlier. It's like, if you have an electrical supply, the cost to do this is really running the pumps. It's an electric bill. Once you have to buy a collector, and you have to put in a system. You put in a little dewatering system, and then more importantly than anything, somebody's got to take the sediment somewhere, because we can't just infinitely pile it up on the bank. But if you have that, we kind of generally consider, our estimates for dredging at Lewis and Clark Lake, if we do it at a large scale, are somewhere in the reasonably $15 a yard. Okay, because you can't put it on that. That's $15 for every yard to pick it up, move it, and put it back in the Missouri River downstream. If you had a source for this sediment, it's very realistic that it may be only a couple dollars a yard instead of $15 a yard.
Less than $1 a yard.
Yeah. So if you've amortized the collection process and somebody's taking it away, at that point you're paying the electric bill to keep the pumps running. And that in a long run, if you get an installation that's permanent and can run for a decade or two, could bring your cost down much lower than any other technology. And it's because somebody's beneficially taking the sediment away. That's the collection is one part, but collection is not the most expensive part. The most expensive part is the transport. To get it I can get it out of the river pretty easily, but I've got to take it somewhere. I've got to get it from point A to point B, whether that be from Springfield to the river below, or to a storage facility, or to whatever. In all of our analysis we do on moving sediment, it's the transport costs that dwarf the collection costs.
Once you find out what's in that sand and what it's been used for.
Yeah, exactly. So here's the beauty of this sand, unlike some other places we work. Chemically inert. We don't have any metals issues here in this area. We don't have any water chemistry issues. This is the type of sand that, here you could run this through a sieve and you could put it in a bag of $4 a bag at Menards, if you could work out that retail workflow type of thing. So while we have a lot of sand, good news is we have a lot of clean sand. Which I can't say it like Fort Randall. You know, I got a lot of real fine sand in Fort Randall, and we've got some water chemistry issues there. It's in a anoxic situation, so if I mix it up, pH of the reservoir goes all goofy on me. But yeah, so one of the takeaways is we've got great sand to work with. Now the trick is who do we convince that they can make something out of it or get it to a place that needs it? We talked earlier, Kansas, in the Kansas City metro area, the Missouri River is cutting down. You hear all these news reports of we've got these barrier islands in Louisiana that are sinking into the ocean because they're not getting sediment replenishment. Where's that sediment that, New Orleans needs? It's right there, right? Because we've cut off that supply to it, okay? In addition, the Mississippi at New Orleans is very channelized. So a lot of their sediment goes right off the continental shelf into the Gulf of Mexico. But a combination of better using what sediment they have and increasing delivery is likely what they need, And these are big questions, and we've talked with MSAC about this. This is not, if you start talking about putting sediment back in the river, it's not just an MSAC discussion. It's not just the city of Yankton. It's not just the village of Niobrara, South Dakota, Nebraska. It is Iowa, Kansas, Missouri, Illinois, Arkansas, Tennessee, Mississippi, Louisiana. All of those downstream partners have say in that if we start reintroducing sediment to the river, because they all have their concerns about what that might do to their local area. Some of them are going to be very much for it, and some of them are going to be very much against it, right? But we don't, as we talk about what the long-term future here is, one of the duets here is probably for MSAC to look, and we're happy to work with them on engaging more of these downstream states. Because if that's going to be a management action is putting sediment back in the river, then those downstream states are going to have a say.
One thing that I didn't understand, or I guess didn't have the perspective until it showed up. We asked questions, and also Paul talks about scaling, is to go down and look at it. It really is essentially like an irrigation pump that goes in the water that we have up and down the river. It really is about that size. So if you did do a small business, out of your farm area or something like that, and you had river access, you could put one of these in, just like an irrigation pump. Only it's just going to be in little ways, and you're just pumping it out of your area for your small business. It is pretty cheap. And irrigation water basically grows crops, so this would be just another kind of a small business. It's not like one big one that goes across the river that's filtering all this out, like he said. So those are a little bit of perspectives that I certainly learned this week. Actually seeing this and seeing it in the water. So it changes a little bit what you could do, and when you add a few of those up along the upper stretches of the Niobrara, pretty soon you are hitting a percentage of sand that's coming out that's not continuing down here or continuing out to Missouri. So
yeah, spend a lot of time on those irrigation intakes, keeping sediment out of them. Yeah, but if that irrigation pump were hardened to sediment and then you separated sediment, you got to use the irrigation water, and then you have a sediment product to do something else with. I mean, anything's possible when we think about it, right? Is there a question over here?
Can the sand be used to make dikes?
Anything you want to make out of it, absolutely.
We could use dikes up along the River First area along the Pocket Creek.
Good, yeah. We essentially, all the levees along the Missouri River are sand core, and then you put a hardened permeable cap of a clay-like material over top of it. We've pitched this idea to NDOT for Highway 12. Highway 12 raise is going to need 1 million yards to fill. 1 million yards. And we're like, hey, we know a place you can get some sediment, And
I don't want the area up there.
that's, yeah, that's,
So with what you're doing down here, does that impact the river flow up above?
it has nothing to do with the river flow. If you were, let's say,
On the creek.
if you were to take enough sediment out, say down here in the Niobrara, you could slow down the rate at which your river stages are increasing up there, because the river stages up there increasing are driven actually by the Niobrara Delta. The fact that all the Niobrara sand drops out right in the Missouri River essentially is creating an underwater dam, and it's getting higher and higher and higher, right? And so as that sediment goes up, the Missouri River does this to match it, to get over it.
Could one of those contraptions that you're talking about be put in the Missouri River that down this way that would get the sediment to where the flowage would go, and the sediment would go to the south, to New Orleans, to the river where it used to go forever and ever and ever?
Yeah, you can put one of these collectors in anywhere that you've got sediment. So you could put in a collection system, just like on the Niobrara, you could put it on the Missouri. That is at a scale
That's larger.
of which this technology has not really been applied, but
Why not do a test on it here?
because I don't have a free piece of equipment that is the appropriate size for this river, but not the appropriate size to not wash down the Missouri. So this was,
Actually, we're gonna test this collector out of Mississippi.
yeah,
If I'm lucky, I'll be able to get out there in the spring. And so.
In Mississippi.
on the Mississippi River around St. Louis.
Right.
Okay.
Right.
Yeah, so we can theoretically put this in the larger rivers if the flows are appropriate.
I would think the Missouri would be appropriate because it's flowing all the time and the channels are moving.
Yeah.
I live up in the Lazy River acres. Farmlands are being lost because of all this stuff. And plus homes, the diversification of for incomes is being compromised. And it's getting worse. At Raider Swanson Road from the Ponca Creek, if this will help to do something like that, fabulous. I
Understood?
think the Corps needs to jump on it and go to the bigger rivers.
So one of the things, maybe to kind of open up this piece a little bit, not to go too deep in it, but one of the other things that came out of phase two is he said there were 3 things or 4 things. This is one. One of the other ones is to find some kind of autonomous or semi-autonomous smaller device that doesn't take a whole lot of people, that can go out, that's basically a vacuum or a small dredge that can go out into an area like this and pull the sediment out of the river and then move it on shore. So that's a little closer to what you're talking about. We did identify one that's out of a German company that does have experience in Europe. They haven't broke into the United States market yet, and I know they've contacted these guys. That's the kind of thing that goes to a little bit bigger water, and that kind of takes care of some of what's already there plus what's going in. So when he talks about the delta, you know, like we capture some sand here, and if it works, but going upstream, that's where you start looking at doing something in conjunction with a one-time dredge project, big project, to get rid of all this stuff that showed up in the last 20 years. If you just did that today without kind of addressing some of it coming in, you know, you get a couple high water events, it just fills back in. But when you tie the two together, where you can start slowing some in, or adding that type of autonomous, or because semi-autonomous, you know, a couple people gets it on shore, we still run into the same issue. You got to figure out what to do with the sediment. But it's a lot cheaper and a lot easier than trying to get a 80-foot barge up here or something and do the same thing with a 10-person crew and go up. So that was identified, and that will be in phase 3. And those are some things that's emerging technology that's not been out there or been used in other places either. And that's something that the Corps and our stakeholders and folks have been very open to look at. What else is out there that maybe someplace else in the world or something like that we're just.
Yeah, we'd love to put one of those autonomous you know, do a pilot project with one of those, because the number one expense in a dredging project is labor. It's the crew, it's paying the people to move the sediments. So we're looking at that. I hope something, I don't have a specific project identified, but we have put up Lewis and Clark and the reach above it as a pilot consideration on multiple times for funding for that.
Other question. Comparative cost to do this, something similar to this on the Missouri, compared to the lawsuits that the government has had to pay out expense-wise for the government. What is the weight? Is one more lopsided than the other?
Yeah, the relocation costs of Niobrara, the lost benefits and all of those, those far outweigh the management costs that it would take to do something about sediment.
Say that again? I want to make sure I understood what you
Yeah,
said.
we paid millions,
Exactly,
hundreds of millions.
exactly. So
That's just a direct statement, but
the cost to do this.
understood.
Is it less than the resettlements? That's what I.
Could be. One of our challenges is when the federal government settles a lawsuit, that money,
It's gone.
well, it's not the same as our money. That's different money. There are colors of money in the federal system. That comes from the Department of Justice, not the Department of Defense.
From all over the place, so.
I understand that,
Right now,
but
I've
I'm
got a
just,
bad taste for
I
government.
understand, but I'm laying out the reality of me going to look for money to manage sediment right here.
That's the same answer as you guys or anybody else trying to pull sand out. If the Corps can't find something to do with that sediment, then it's just as expensive for us to do it too. So if we don't have a partner that wants to take it away, or if we can't bypass it around the dam, we can't afford to do that either.
Right, and my argument,
You can run the machine and you can pull sediment out, but managing the sediment, once you own it, is very, very expensive.
I understand.
and my argument that it would cost more to do nothing doesn't carry any weight in the current way that those things are considered.
So when you say take the sediment away from the dam, are you talking about like pulling it out here? I want to make sure I'm understanding. This is new to me. And I've been away from the area for 50 years. A long time. And I've seen what's happened in those 50 years. So what you're saying with by pulling this sediment out and moving it down beyond Gavin's Point is what you're talking about, the expense of that? Is that what?
Yes,
We don't know the expense of these things, so it's all kind of speculative, so we really can't answer those questions.
Test right now.
yeah, on this little one, but I'm just saying, in my statement earlier was on general, any project to move sediment, whether it be here or wherever else, picking it up is the cheap part, moving it somewhere is the expensive part. So if we can bring down the cost of the moving it somewhere part, that's where the numbers we try and get into our favor,
I understand.
type of thing.
The
So
calculation I use is $10 per ton per touch. So it's gonna cost you at least $10 to get it out of the river. It'll take you $10 to put it on a boat, $10 to move the boat, and then $10 to unload the boat per ton. So $40 a ton to move stuff from A to B. And if you're in New York, dealing with contaminants, it's gonna be $140. And if you're in Guam where there's no equipment, it's $240. So your location matters. And I'm trying to give sand away in glacial Illinois where there's sand all over the place too, and you just can't do it.
yeah, that's a big driver. No, that's fine. That's absolutely fine. That's, that is our driver here. And so that, and we kind of plead to everybody. It's like, well, what are your ideas for monetizing this resource? If you could, if you could find the golden ticket right there, that's what changes the economics to justify sediment management, because we have a lot of benefits we're trying to protect. Unfortunately, right now, for a traditional sediment management action, like a big dredge project, that where we would, dredge at the delta year after year after year, something like that, the cost of a project like that is a lot more than the benefits that we're saving. So I got to get that cost down so that the benefits I'm saving are more than the cost of the move in the sand, right?
Okay, let me ask, and this is my last question, and I do ask questions.
Fine, that's why we're here.
Okay, I'm gonna use Missouri as an example. A lot of cropland has been lost.
Mhm.
Because the channels are changing. The banks are being eroded. So if the sediment that is accumulated where the channel was maybe originally,
Mhm.
could the sediment taken out of there be put back?
Yes, yes, you're right, and I'm gonna answer for him because, yes, that's one of the things that you look at beneficial uses, and that's used in the coast and the larger harbors where they have commercialized effort, but some of that is returning that back to the land so that you can create that, so.
So then you could farm it again?
Well, that gets to be a little different
Well, it
question.
depends on the
It depends what it is and how it is, but as far as returning some of that, yes, and again, you're back into, we get it on shore here, where is that at and where does it need to go, and transport, but yeah, that's an option of.
Yeah, there's nothing to say you couldn't capture some of the sediments that are in the current river, remove them, which would lower the river there, and place them on the land, and which would effectively kind of raise that land, and that would. I guess it could, yeah, in theory, change the production on some of that land, because there was a lot of row crop, then it was hay, now it's Phragmites and cattails and all of that. So yeah, that's one thing to consider. Yeah.
Can you do my rah-rah speech now, Scott? Is that okay? All right.
Let her rip.
Well, we want to thank Stacy and then for bringing the kolaches and cookies.
Yep, right on.
You guys for doing this and the Corps of Engineers and Scott and MSAC and Mark. Let's give them a big round of applause for this important big step. Exactly. Very short. 23 years ago today, and I'm going somewhere with this. We all know what happened. I was there. I was next to the Washington Capitol. I firmly believe that if those people in Pennsylvania would not have taken over that plane, I wouldn't be here today. Because we were there, and we went by the Pentagon at 9 o'clock. So it's my usual tradition, we get 3 Our Fathers and 3 Hail Marys as a prayer for them today. And we also, did a moment of silence for what they did. It was a sad day, but now we've got an opportunity to do something even better. How many of you remember Virgil and Virginia Regal?
Yeah.
Their cookies and their desserts built that bridge. You guys know that story? And Raider Swanson's after-hour drinks at the pub, he built that bridge. There was 7 to 10 of those people that were committed to that project, and they never gave up. Tonight, you've got 21 people here, 22, 23, whatever. If all of you get involved and stay, and there's more on the South Dakota side, you can make this a reality, but you gotta stick together. You gotta stick together. Tom Brokaw called it the Standing Bear Bridge, the bridge to nowhere. Remember that? And we called it the bridge to everywhere. They all cooperated. Cap Dirks served in the legislature with me. All these people stuck together. Sandy Corvo, Stockholm, Weiss is on the phone. All you people have stuck together. Now this first step, if you can get it to work, is going to lead to some dramatic changes. And you got to look forward and not back. And you can certainly believe that, of course, Chad Gurney, the senator, moved that bridge, moved the dam closer to Yankton, and that was a mistake. We see that now. But now you've got to move forward. You can't live in the past and take it forward. So again, I just want to commend you for what you're doing. This is the best project I've seen in all the years we've belonged to this organization. When we had enough money, we paid to do it, Mark, when we didn't, we couldn't, of course. But, we just commend you for taking this important step. I just want to say thank you for doing it. That's all I could say about that.
Thanks, Frank. So we'll kind of, we went a little over, but it was good discussion and good question and answer. So yeah, to kind of wrap it up, if anybody would like to go tomorrow night, I have a sign in, or Friday morning. We've got some seats if you want to walk down and see it. For those that are MSAC members and stakeholders, again, thanks for coming and thanks for being online. I know Frank counted heads here, but we have more online. If you're not and you would like to join and do individual memberships, we have a number of organizations that are organizational members and that serve on the board, to include government agencies too. So you may be a part of one of those as well that has some view or some impact or some shared interest in extending the lifetime of the dams and the rivers and the reservoirs. So yeah, thank you. So this is a big step, and it's been 20+ years coming for a lot of these folks. So a lot of hard work on their behalf.